Okay, it is right at the top of the hour, and we have a pretty full agenda today, so I think we should get started. Sound good? All right, so welcome everyone. This is IPPM, IP Performance Measurement. I'm Tommy Pauly, one of your chairs. Marcus here is a new chair joining us, so please welcome Marcus, and thank you, Marcus, for stepping up. Ian is stepping down as chair. I don't see him here, so we may need to just bid him adieu virtually on the list. But he's been very helpful for the past year and a bit. Okay. This is pretty far into the week, so you've probably seen the note well before. If you haven't, if this is your first group of the week, this is essentially describing all of the requirements and expectations for participating in IETF meetings, the various processes we have around IPR, as well as around how you participate. And one thing we want to highlight specifically this time is just some of the aspects of the code of conduct. This group, I think, for the entire time I've been here, has been very good at interacting well with each other, but it's good to just remember and have it at the forefront of our minds as we're interacting in the group that, this is a group with a lot of different people from different backgrounds, and the most important thing we can do here is to treat each other with respect and to make sure that we're clear and making it easy for everyone to understand and participate, and that we focus on having, technical discussions that are getting at the details so that we can help progress the work, not getting into anything personal or just trying to stop work. And we're trying to find the best solutions for the whole internet. So just keep this in mind in your contributions at the mic and on Jabber. And I am looking forward to a great meeting. For the meeting management, you are here. You are in Meet Echo. Just as a note, when you want to queue, use the little join queue hand sign. That's up by your name on the side of Meet Echo. You can turn on your own video and audio. If you are a presenter, all of the slides are preloaded through Meet Echo, and there's next to the hand button, there's the file button that allows you to share slides. You'll be able to request sharing slides when someone else is no longer sharing slides. We do have a lot of presentations and a number of quick elevator pitches, so there are 20 slides preloaded in here, so make sure to grab the right one and be ready to do that. The notes can be found here. I guess they're no longer Etherpad. We should update that on the slide. They're in HedgeDoc, but you can find them here, and Lucas is helping us take notes. And yeah, and if you see someone in Jabber trying to say something at the mic who can't get audio, please relay that, and Marcus and I can watch that as well. Okay, so on to our agenda. We're going to start with a good amount of time, about an hour, going over our primary documents, the things that we currently have adopted. In the working group, we have some new things that we adopted since last time around IOAM that we want to spend a bit of time going over. And then in the second half of our meeting, we have some new proposed work. Specifically, we have 3 documents that we want to go over with 10 minutes each. And this first one is related to some work that came out of a recent IAB workshop on network quality. So that is some of the background of the discussion that happened there. But all of these had some discussion on the list and interest from the group. And the remaining time will be a number of quick elevator pitches. We're trying a new style this time, where rather than trying to limit based on time, we want people to summarize what they're doing within a single slide so that we can get all of the information up front and hopefully save more time for discussion and feedback, and not just be trying to fill up the whole time of the lightning talk with just a presentation of blasting information at people. All right, so that's all I have. Welcome, Ian. And we already mentioned that you will be stepping down, and thank you again for your service. All right. Is there any agenda bashing, or should we jump right in? Okay, I don't see anyone coming up. So our first presentation will be about some of the IOM data integrity and deployments. And Frank, if you could ask to share slides.
Well, volunteer to go and do the session for us this time on IOM. I just got my third jab yesterday, and I'm kind of okay, but I'm not feeling that well.
Well,
glad you got it. And thanks for that.
Yeah. Okay. Thank you, sir.
So here we go. This is going to be a quick update. I hope we'll have more discussion time since we have 25 minutes allocated for these two drafts. These were the two new drafts which were initiated because of the feedback that was received on the IOM data draft. Both these drafts were adopted between last and this just before this IETF. We had discussed data integrity draft in the last two IPPM meetings, and we had a bunch of options to meet the data integrity requirements for the IOM protocols carrying IOM options. The changes, just highlighting the changes that happened while we adopted this work here. First major change was changing it from informational to standards track, because we are defining integrity-based options which are parallel to the IOM data options that are defined, or IOM options that could be defined in other drafts like the direct export draft. Then we, based on the feedback from multiple folks in the work group, we adopted method 3, which is a symmetric key-based signature to protect the integrity of the options as the proposed method, and all the other methods that were discussed earlier were in the appendix that got removed because as part of the adoption and feedback received during the adoption call. And there were some editorial changes done. For example, we had given examples specific to the options that are there in the IOM data draft, but had not explicitly mentioned options in the direct export or any other IOM drafts that could come up in future. But data integrity is quite generic. It should apply to any IOM options that are defined in beyond the data draft. That is fixed now, and some terminology fixes we had called we were not following the nomenclature used in the data draft, which is now fixed. So we do have additional feedback and some of the internal discussions among the authors to improve the security sections. We definitely want more input on. We have AS256 and SHA-256 plus ECDSA based algorithms that could be used for carrying out the signature, but we appreciate feedback from other folks more familiar with what would be other reasonable combination of hashing and signature algorithms that should make it into that list. And more reviews on the integrity methods that is adopted is appreciated. And plus, if anybody wants to try out the implementation of the data integrity option, especially in the kernel or in VPP where we have the IOM data options implemented, that is appreciated. Okay, so that was about the data integrity draft. I'll just cover the deployment draft and then we could have discussions unless somebody has questions and we want to stop here specifically on the integrity draft. Okay.
Actually, I just jumped in queue quickly. A couple questions on the integrity draft. So yeah, thank you very much for the work on cleaning it up, kind of consolidating down to one option. The two questions I wanted to check on was a status of implementing this solution and testing it to see, how does this impact kind of the existing IOAM code bases and deployments. And then the other question is, should we, as a working group, be requesting early sector review, and when do we think we'd be ready to do that, to get that input from the security area?
On the implementation, I think it's open for
Looks like we may have lost.
Yeah, Frank? Hit the wrong button. I don't know. I'm not aware that anybody is coding the thing up right now. I'm not sure whether Justin is here, who is driving most of the work on the kernel. Yeah, we have Justin here. Maybe he can go and speak up from his perspective on what he's considering doing for either the kernel, or he has colleagues also working on the VPP implementation, so I'm not sure where that work is. But I'm not aware of anybody else being actively coding this thing up, so maybe we can have other people speak up here. From a review perspective, I think once we have, I would not feel comfortable going for a security review unless we have completed the security section, which is one big leftover in the draft. So that's something that we want to go and fill in. That was a little bit of a hush-hush. Well, Tommy, when you kind of pinged me, can you get that out? Yeah, I could get that out. But there is still a little bit of work to be done on the draft, I think, before we want to go for a proper security review. And I think that's sort of fitting in Section 6 is mandatory. That's what I view.
Great. Okay, so essentially our next step on this draft is filling that in, and then once that's done, we can get a security.
Yeah, along with what Shweta is also asking, right? So we have two combinations listed right now for what people want to go and do from a signing perspective and the likes. So what algorithms you would appreciate. If there's others that people see as high priority, let's go and speak up on the list, please, so that we have a relatively comprehensive set of things included, so that we are, at least, I think, from a working group perspective, given that this document is really a document that has been kind of shepherded and requested by the working group, that we have a relatively good representation of what is in there. Right?
Yeah.
So please speak up and voice opinions of what you want to go and see included, so that we're comprehensive.
Yeah. I would suggest that a small set of algorithms, like just let's choose kind of the best ones that we need, but not too many in there, because that oftentimes is a bad practice.
So it's one for symmetric and one's for asymmetric. But if people have strong feelings around other things, then let's go and get that in. And as I said, I think we can probably give it another round for the next meeting that will hopefully be in person, and then maybe we are sure enough to really ask for a security review, which is something that I would appreciate when earlier.
Great. And hopefully we can also find out from implementations, which algorithms are convenient for them to use or most conducive to their code base. All right. Thank you. That's all I had.
Thank you. Sorry for the network glitch. I'll continue with the deployment draft. Again, this was adopted recently, and we have revised it based on basic feedback that was received. Some of the feedback is addressed in the current 0.0 version of the workgroup draft. We aligned the limited domains per RFC 8799, and again aligned it with the IOM data terminology, which was good feedback that we received. And we are going to continue keeping this alive. We want to keep it up to date with the new deployment experience that we have with the kernel implementation, as well as another open source implementation in FIDO VPP. We do have IOM support for Wireshark, which we need to update the draft with. Further reviews are appreciated.
And before we go into the discussion, I want to go and give a big hand to Al Morton, who caught a load of nits. And so thanks, Al, for all the feedback that you've been given to improve also the language in the draft.
Like, show in the queue. Shaman, do you want to speak up?
To the IOM format draft during the working group adoption poll of this draft, I sent my support and also a suggestion to include IOM encapsulation over beer into this draft, the scope of this draft, but it's not in the 0.0 version working group draft. I checked that, so I want to know, is there any special reason why beer OEM is not included?
We have not addressed. Sorry, go ahead, Frank.
Yeah, you can blame me. I think I forgot about that. I'm sorry for that.
Okay, thank you.
We'll fix that. Good point. Thanks for bringing it up. I'm sorry.
Okay, thank you.
Okay, I can stop sharing. Tell me if there are no other questions.
Yep, that sounds good, and I think we gained back a lot of time, which is very helpful. So all of the other presentations will appreciate it.
Thank you.
So next up, we have IOM conf state. And Shaman, do you want to come back up for that? Great.
Is my slide okay to you?
It looks good to me.
Okay, good. Thank you. Thank you, Tommy. Hello, everyone. It's Xiaoming speaking. This presentation is on echo request reply for enabled in-situ OM capabilities. This is a working group draft, and the latest version is 0.1. 0.0 version of this draft has already been presented at the last IETF. This is the summary of the two main updates in this revision. Firstly, this revision changes the format of IOM capabilities query and response from TLV to container. The reason is that for ICMPv6, and taking example by RFC 8335, IOM capabilities query is not a TLV of echo request, but the echo request itself. The same goes to IOM capabilities response. It's also not a TLV, but the echo reply itself. Secondly, this revision changes the format of response contents from sub-TLV to object. And the reason is that for ICMPv6, the extensions contained in echo request or reply are not sub-TLVs, but objects. Also note that in 6-man working group, the 0.0 version individual draft draft shell 6-man ICMPv6 IOM conf state has been posted before IETF 112. And this new individual draft has been presented in 6-man working group on Tuesday. My personal feeling is that I've got positive feedback from there. The internet AD and 6-man chairs have no objection to extend ICMPv6 for IOM capabilities discovery, as long as the IPPM working group has a rough consensus. It's the right way to proceed. This slide is about the first main update that changes query header and the response header from type length to container header. This figure shows the instantiation of container header for ICMPv6 IOM echo messages. It can be seen that the container header of ICMPv6 does not include exactly type and length. It includes type, code, checksum, identifier, sequence number, and a number of namespace IDs. So this change is needed. Also note that for MPLS LSB ping, SFC ping, and BR ping, the container header is also applicable. This slide is about the second main update that changes response contents header from subtype length to object header. This figure shows the instantiation of object header for ICMPv6 IOM capabilities objects. It can be seen that the object header of ICMPv6 does not include exactly subtype and length. It includes length, class number, and C type. So this change is needed. Also note that for MPLS LSB ping, SFC ping, and BR ping, the object header is also applicable. Except for the two main updates, there are also some other mentionable updates. The first one is that a list of namespace IDs must be included in an echo request. In last version, may is used here. We think master is more appropriate. Specifically, if no any other namespace ID than the default one, 0x40 is provisioned at the IOM encapsulating node, then the default one must be included. If other namespace IDs than the default one are provisioned at the IOM encapsulating node, then the provisioned namespace IDs must be included. And the second mentionable update is that for the feature described in this document to work, more optional preconditions are provided. They include explicit path is used, or only one path can be used, or echo request message experiences the same ECMP processing as the data packet. The third mentionable update is that one new W bit is borrowed from the reserved field of IOM pre-allocated tracing capabilities object and the incremental tracing capabilities object. It's used to indicate whether the object carries a 16-bit egress interface ID or the object carries a 32-bit egress interface ID. So next steps for this draft, we authors ask for more reviews and comments. We'll revise this draft to improve it. And then we'll ask for working group last call. Thank you.
All right, thank you. Frank, go ahead.
Comments. The first one is, if you go back to slide 6, what we seemingly do right now is that we have a kind of opinionated choice of what we want to go and get included into one of these echo replies that you're transporting back to the requester, which is kind of a bit field that we come up with here, right? And it's inspired by the data types that we have in the data draft, but it's not the same. Rather than coming up with kind of new definitions here, would it make sense to rather come up with an encapsulation or a translation of the Yang model that we have that describes the various fields into an encapsulation, into your container that you want to go and carry in your protocol? I think that would make much more sense, and it would avoid the redefinition of fields rather than, what we have here. So I think aligning that and coming up with a mapping from the Yang model that would go and be encapsulated over ICMP or whatever carrier protocol you want, I think is the cleaner approach. That's at least my suggestion. And the other point that I have is we are starting to use ICMP as a network management protocol. So we should also go and treat it as a network management protocol here. In the security section, you say, ICMP can be eventually secured with AH or even ESP headers included. That's fine, but I think we want to go and adopt language that is similar to what we use, say, for instance, in the netconf RFC. So there should be less cans, but more shoulds of what you want to go and use, so that we have proper security in place, because you probably need at least some form of integrity checking, and even more, right? Because you can retrieve a load of configuration information from the nodes this way, between the requester and the responder. That's it. Thanks.
Thank you. I think I know your comments from previous IETF meetings, but I'm not sure how can I encapsulate the Yang model data into this response message. So is that your first suggestion, to include Yang model data into the response?
Go and build an encoding for the Yang model, similar to what we've done for netconf, right? Into what you're transporting here. And that would align that we have indeed like the Yang model represented in the communication that you do between the nodes. Because end of the day, I think what you have with ICMP, you define a container and then you just ship messages over that particular container back and forth between the node. And I don't really see a reason why we should go and treat ICMP as a different protocol than any other network management protocol that you're using here. Right, so
the reason
the wheel for a specific, let's not create a specific encapsulation of a network management protocol into ICMP, rather than we have something generic for managing individual ICMP, individual IOM nodes, and let's stay with that, and then you just treat ICMP as a carrier or beer as a carrier or whatever.
To my understanding, if we use netconf here, then we need to establish a netconf connection between the encapsulating node and each transiting node, right?
Do netconf, but I think you need, given that you want to go and carry network management information over a channel, you don't want to use netconf. You're creating your own now transport protocol using ICMP. But I think there is no need to go and redefine what you do from an object's perspective, because that is in the Yang model.
The reason why we choose, the reason why, okay, Tommy.
Yeah, I think we're a little over time on this item. We're overall ahead on time, but I think this is a great discussion. I think this is a good point to drill into, and maybe this is something that, Frank, if we can take this to the list and just kind of go in depth on the different options about how we can not end up reinventing the wheel for the signal. I think that would be a good discussion to have there.
Okay.
Does that work for everyone? All right. Any other questions or comments on this? Okay, doesn't look like it.
Okay, thank you.
Yeah, thank you very much. This is good update.
Okay.
Let's hammer out the details. Be good. All right. Next up, we have explicit flow measurements, or I want more than one spin bit. All right, Mauro. Great.
Hi.
Hello.
Hello.
Hello. We can hear you. Do you want to share your slides using the preloaded slides?
Yes, you can share my slide. Can you?
You can drive it yourself. So if next to the hand icon, there's a little document. Yep. So if you click on that little file icon.
File icon is this.
So,
okay. Yes.
Yep. Exactly. And so now I'm going to approve you, and then you should be able to look through all of the slides and find the one that's yours.
Okay. Stamp extension. Okay. Network capacity. Ongoing network. Okay. IPPM improvement. Stamp routing. I mean, at the end, perhaps user device.
Should be in there. Explicit.
I can find it. Okay, thank you. I find. Share.
Oh, good. Good. There we go.
Okay. We can start. Okay. You can hear me? It's good, the sound? Okay, we can start. Okay, I can summarize in a simple sentence the explicit flow measurement concept. The explicit flow measurement techniques employ few marking bits inside the header of each packet for loss and delay measurement, protocol independent, evaluable for encryption either in protocols in particular. The metric described in this draft are several. The first one is the RTT matrix that we expand the first idea of spin bit with the idea of delay bit and the new idea of hidden RTT that it can be applied both for spin bit and for delay bit, because it's possible to delay the signal from a certain amount of time in order to hidden the real RTT for people that are not allowed to understand it. After there is the round trip packet loss that is made using the spin bit and the round trip loss bit, the T bit. And finally, there are two options for the one-way packet loss. The first one is the square bit, that is already known techniques in 8321 RFC, and the loss event bit as a second bit, or in alternative, the square bit, the same bit with the reflection square bit that reflects from the other side the square wave that the qubit generate. There is some implementation both in the hackathon and in the field. In the last hackathons, we experimented with other companies, for example, Ericsson, Huawei, and so on, some experiments about this quick measurement. There are some implementation in the field. The first one that we display in this transparency is the Telecom Italia implementation on Android mobile phones. That is inspired the draft about user devices monitoring that is presented in the last part of this meeting. There is the Ericsson implementation, core network probes that detects the spin bit alternate marking and make the measurement. The Orange Akamai implementation, that is the first one that implement on the field the packet loss using Q-bit and L-bit. The Aachen University had an experimental implementation. They presented a paper in NRW that compare all the techniques that we described in this draft, L-bit, Q-bit, R-bit, and T-bit, and they experimented it and concluded that they works with various pros and cons. And finally, also Huawei is starting to work on the topic and will present in next hackathons some experimental trials. Okay, some words on the hidden bits. That is the last bit that we introduced in this draft, in the version that we presented in July. The idea is born because the spin bit is not so much implemented. We, using our devices, we spread some probes on our mobile phones that Telecom Italia uses for some experimentation in our network, and we saw that there isn't marked packets inside the Quick. Quick is quite used, for example, by Google application, but also Facebook application and many others, but no spin bit is marked. So this implementation that is defined as not mandatory in the standards, in the RFC 9000, is not implemented in the field, in Italy almost, but I think all over the world is the same. So we think that to add a feature that we have the hidden delay bit, but it's possible also to have the hidden spin bit in order to mask the real RTT, and introducing this simple mechanism that adds some delay in the reflection. So the packets are reflected. The real traffic works in the same way. There is no delay in the real traffic, but the marking is delayed. So it's possible to mask the real RTT, but it's possible to have some measurement, both knowing the time that we added, but also not knowing it, because if the measurements are between an observer and another observer, or between an observer and the server, the measurements are correct. The end-to-end measurement is not visible unless you know the additional delay. Okay. The main changes of this draft. The main change, the first great news is the IPPM working group adopted this draft some days ago, and we updated the draft, the new version of the draft, adding the new name and introducing a couple of changes that are suggested during the working group adoption call. In the introduction paragraph, we underlined the beneficial approach of the methodology described inside the document as per the RFC 9065, thanks to the Nicholas Kahn suggestion. So this kind of methodology is beneficial in this case. And we updated all the references using the new RFC that are standardized. So the RFC 90,000 and 9065. So we updated all the references. Next slide. Okay. This is the summary of all the methodologies that we present in this draft. The idea is this draft is not to make clear choices of one methodology instead of another, but we intend to present all the possibilities. And then we had the intention to present in specific working group that are devoted to a specific protocol the right choices for this protocol, because a kind of marking can be useful for a protocol and not so useful in another protocol. A clear example of this idea is in the slide that we presented, the lost bits summary. Because the main two methodology both uses the square bit as first bit to mark, because it's a very simple technology, well known because already implemented in field using the RFC 8321 as a reference. But we have to add another bit to have end-to-end measurement, because the square bit for its nature is not to end-to-end measurement, but is origin to observer measurement. We can measure only the loss between the origin, the client or the server, and the measurement point, because we mark the blocks of 64 packets. And if the number of packets marked with the same color, 0 and 1, is less than 64, there is a loss between the origin, client or server, and the measurement point. So to have end-to-end measurement, we have to add another bit, the loss event bit, as proposed by Akamai and Orange in their draft that we joined with in this draft, or the Team Telecom Italia proposal to add the reflection square bit. The loss event bit generates a market packet every loss detected by the protocol. The reflection square bit reflects the square wave on the other side, so it's possible to measure the round trip loss using this reflection. All the two methods are quite good, as the Aken paper demonstrate. There are some differences, because the loss bit, the L bit, is very simple to implement, is more simple than the reflection square bit, but it is dependent from the protocol. So if the loss is detected in the protocol, the L bit is marked. It's not detected, it's not marked. So it works well with QUIC. So in our opinion, can be a right proposal for QUIC. It works less well for is less good for TCP, because, for example, the ACK packet is not detected as lost. So if ACK packet is lost, the protocol, the TCP, doesn't measure it is lost. So it's better to use for TCP, in our opinion, probably the R bit. But this is, as I said before, this is only a general review of all the possible techniques. There is a next step will be to select the best bit to mark for each protocols. Next, we can show the slide. So we have many possibilities. If there are only 2 bits for explicit measurement, there are 2 possible options. In our opinion, is the most significant: the spin bit and the T bit, to have the round trip time and the round trip packet loss using only 2 bits. But the T bit is less precise than using Q bit and L bit, or Q bit and R bit. So we propose to use only if we have only 2 bits and only 1 for the loss. The option B is to use the D bit or the masked delay bit, the hidden delay bit for RTT, and to use the one-way packet loss, the Q bit, for the loss. In this case, we don't have the end-to-end measurement for the loss, but only the origin to probe measurement for the loss. So it's a compromise if we have only 2 bits. If we have 3 bits, that is the best option for performance monitoring on using explicit measurement. And for example, quick is possible to have, it's not defined till now, but it's possible to have 3 bits. There are 4 options that we have to have a choice. But the first one is to use for RTT the spin bit, or the hidden version of the spin bit, if can be useful to mask the RTT, and to use for the one-way packet loss, Q bit and L bit, in order to have origin to measurement point loss or end-to-end loss. The option D is very similar. There only the substitution of spin bit with the more precise but not so well-known D bit. And the option E is equal to the previous one, but we introduce the R bit instead of the L bit. This can be useful if we don't want to have a measurement that depends from the protocol, because the L bit signals the losses detected by the protocol. If the protocol doesn't detect the losses, the L bit doesn't signal the losses. The R bit is independent, so it's more complicated of the L bit, and the other problem is that there is a delay in the measurement, because we have to wait a square wave of the Q bit starting from the client, reaching the server and converting in the reflected square wave and come back. So we have 2 round trip time more plus the time of the square wave to complete the first measurement. But the L bit, instead, the L bit is very quick, because there is a market packet when the protocol detects. But in this case, the R bit is totally independent from the protocol. So if also the protocol doesn't detect the loss, the R bit can detect it. Okay, the last slide. I respect the time for 1 minute. Okay, so we can conclude some thoughts about this draft. There are some implementation, there are some on-field implementation. The IPPM working group adopted the draft. We presented some sibling draft. There was another one in this working group about the positioning of the probes. The idea is to positioning the probe in the client, because so we can save hardware using the hardware of the client to make also the measurement, and some advantages that we explain in the presentation at the end of this meeting. Another sibling draft is presented in this session of the core working group about the COAP protocol. That was another protocol client server that can have some extension to have some additional bit for marking. So we think that it can be a good idea to present this. In the future, if the working group are interested, we can try to present an implementation for Quick, having a choice of the right bits. Okay, this is all. Thank you.
All right, thank you. We do have some time for questions. I've seen some comments in the chat trying to clarify the hidden bits and exactly what each party can see and what can still be measured with them. So it'd be good to clarify that maybe.
Okay, the hidden bit, the idea of a hidden bit can be applied to every bit that measure the RTT, because it can be applied both for delay bit and for the traditional spin bit. The idea is to delay the reflection of the packet that detect the square wave for the spin bit, or the delay sample that is the single marked packet that is used by the delay bit. So when, for example, for the spin bit, when the square wave that is the front of the square wave that signal the starting of the RTT or the ending of the RTT arrive to the client don't reflect the end of this square wave immediately, but it continue to mark the packets with the same bit. So if we are in the one period, for example, the RTT is 10 milliseconds, and the additional that we add is other 5 milliseconds. So when the square wave reach the client don't change immediately the front, but it wait other additional 5 milliseconds to change the front. So the observer don't measure the write RTT, but the write RTT plus 5 milliseconds. This masked only the end-to-end RTT, because if we measure using a probe the RTT between the observer and the server, for example, the server don't add anything, because it works in the same way that it works for the normal spin bit or normal delay bit. So the measurement observer, server, observer, the RTT is right. So it's possible to segment the network and to have a partial measurement correct, but not end-to-end measurement. The only measurement that is masked is the round trip between client and observer.
I see. Okay. And the only extra delay is added on the client side, not on the server side.
Yes, only the client side.
Perfect. Okay. And I think that's roughly what the chat was getting to as well. But that is helpful to have clarified. All right. Any
it's
other
possible to choose this adding time in many ways. We propose to choose a fixed amount for each client. So the position of the client is moved for exactly the same amount of time, so the same amount of kilometers, let me say, for all the time. So it's impossible to detect if there is the right distance or a fake distance, because they add always the same amount of time.
That makes sense. All right. Thank you.
Thank you too.
Okay, next we have the draft on connectivity monitoring. Let's see. Rudiger, are you able to find your slides in there? There we go. Great.
To find it. Thanks. Yep. I made the presentation before I updated the draft, so this presentation refers to the older version. I meanwhile updated the draft on Monday, and it contains packet loss-based specification for a connectivity metric, which is just announced here in this. I also have changed the status from standard track meanwhile to experimental, because I think that's more suitable. I'm not able to come up with an implementation very soon. So I think that's fair. I think I moved to the other slide. Yep. And that is indicating how the loss-based connectivity metric is going to work. The router sketch, which is on the upper part, is already part of the other presentations. And there are 3 measurement loops passing each connection or path to be monitored. And 2 go to the same direction, always per upstream or downstream. And there's always a contra direction, and there's only 2 measurement paths going per direction, either upstream or downstream. And the idea then is, if there is no packet received within one measurement interval inc t on all of the measurement loops per monitored interface, then you decide on connectivity loss. And the simplest definition of distance between two packets per measurement interval to me seemed to be to wait for the measurement loop which is producing the longest measurement loop delay, and then double that amount and simply send packets only after that has passed on each individual measurement loop. That means you only send a measurement packet along the next loop once you've received that of the last one, which is maybe not the fastest way of operating it, but it's pretty reliable, I think. And then you simply count whether you have all those passing the connection which you monitor. And I've used the colors to illustrate that down there. And once you did not receive them within the time when you send the next one, and it doesn't matter in which order you do that, then you decide that this connection has failed. The whole idea is to overlay all these measurements. So what you see here is the individual combination of measurement loops passing this monitored interface. And if you are interested in details, the terminology is adapted to try to illustrate that as good as possible. And you can read how that works. And I'd, of course, be happy for comments. And I'd like to add that the question about timing has been put to me several times. So I think, or the intent now here is to answer these questions and come up with a scheme how it works. All right. And that is it from me.
It looks like Greg is in the queue.
Yep.
Still, I'm not really comfortable with the terminology because traditionally the connectivity is state in fault management OEM. So, and if there is a connection, so actually when we're referring to something as a connection, we understand that it's not only ability to receive test packets, but on that connection that belong to this connection, but not receiving packets from other connections. So basically, absence of misconnection state. And misconnection definition is usually specific. At IETF, since we are dealing primarily with the IP and MPLS, if it's IP MPLS, not traffic engineered, then we usually refer to the loss of path continuity. And the protocol that used to that extent is bidirectional forwarding detection, BFD. And one of the things that property of BFD is that their session goes down or path loss continuity state declared when I lost 3 consecutive test packets. And even though the protocol supports doing that on the first packet, on only one lost packet, there is a good reason to have 3. It's not only similar to how Ethernet OEM works, but it provides certain stability. I'm somewhat concerned that in this proposal, there loss of connectivity declared on a very first packet. Because then if that's the case, then so the next packet, what? The next packet will mark the connection as up. Then we'll have probably states bouncing up and down interchangeably if we have a flaky connection. On the other hand, the packet loss ratio or some other statistics will indicate that the connection, the path is not stable. But from the fault management perspective, bouncing states and generating alarms and clearing alarms, that would cause a lot of confusion. So maybe that's something that needs further discussion and look at, and especially how it relates to the fault management OEM.
Yes, adding some text with a relation to fault management OEM. I probably need to do that. I'm not a BFD expert. The state of lost connectivity is declared after 3 packets have been lost. If you look at the illustration below, it's that red link LSR to LERI is disconnected. That what the text says also in the draft is you start with sending packet F2 index 1, and then you send F3 index 1. And the expectation would be if you send a packet at T2, it should have been received at T3. If you send one at T3, it should have been received at T4, and so on. And if you look at the blue one at time T5, it should have been received at T6. So these are 3 packets. And if they haven't been received until T8, when you would send the next packet on F2, then you declare the state to be disconnected. So yeah, it's 3 packets. 3 packets which should have been received for a long time then, or some time then, at T8 when you declare it to be disconnected.
Yeah, I'll be happy to discuss with the BFD because I'm working on it extensively as well.
Yeah, sure. That would be helpful.
Yeah. Okay, we can continue discussion on the list.
Thanks. Yeah, I would appreciate it.
All right. Thank you. Right on time.
Thank you.
Perfect. Okay, and last of our adopted documents, we have the SRPM work. Markish? Great. Do you want sharing your screen, just share the preloaded slides? Instead of the screen button, you can press the document button. Do you want to try click that again? Sorry.
Yeah, you see it.
No, can you click the document button one more time to ask to share?
Okay, I canceled it and I'm asking again.
Here we go. Yep.
Yeah.
You are now granted.
You see it. I'm sharing it now.
We do.
Okay, great. Yeah, hi everyone. My name is Rakesh Gandhi. I'm presenting the very quick update on the STEM extension for SR on behalf of the authors listed. So agenda is a brief update on revision 02, just to highlight the work happening in other working groups on STEM extensions and next steps. So there is very brief minor updates in revision 02 mostly editorial changes. We converted Diana into table format. We have no open issues at the moment. There is extensions that builds on the great work done by IPPM with STAMP. Spring has 2 drafts on SRPM, and also there is one in MPLS with new encapsulation for pseudo wires. So welcome your review comments on those drafts as well. Just we are seeking more review comments and suggestions for this draft, and we'll wait for maybe one more IETF before we request a last call. So that's all I had. Any comments, suggestions? Thank you.
Yeah, thank you. Okay, and now we're going to move on to our proposed work. Actually, before we do that, there was one thing I forgot to mention in the slides, which is we did publish RFC 9097. So I just wanted to say congrats to those authors and thanks for getting that work through. All right, Christoph, I'm going to approve you here. We can get started.
Okay. Hello, can you hear me? Can you hear me fine?
Good. It's good.
Great. Cool. Hello, everyone. I will present our internet draft, Responsiveness under Working Conditions. And as this is the first time I'm presenting it, I'm giving a little bit of start with a little bit of background first. So first, what is it actually what we are trying here to solve here? What are we trying to address here? So the first problem is that we realized is there have been 10 and more years of buffer bloat, in the sense that it was made very public more than 10 years ago. Solutions quickly started popping up and were being standardized and implemented. But still, today, buffer bloat is a very common problem. And why is that? One reason we believe that is the reason is because there is, first of all, a lack of awareness and a lack of tools. The awareness of buffer bloat for the end user would allow to use the end user as a forcing function to drive the solutions to being deployed. And a tool that allows to measure it would allow to actually measure the buffer bloat and allow operators, vendors, and so on to build benchmarks to minimize buffer bloat. A second problem that we realize exists is there's not really a clear definition of what buffer bloat actually is. And if you ask different people, you will get different definitions of buffer bloat. It's also not clear how you can measure it. Is an ICMP ping while doing a file transfer good enough? Do you need to flood the network with UDP traffic and then send TCP request response? DNS, can you use DNS to measure buffer bloat? Right, it's not really clear. And there are some tools that exist, like DSL reports, fast.com, waveform, and so on, that are measuring buffer bloat. But if you compare one tool with the other, they have hugely different methodologies. And when you run the tools, they provide completely different results. So it's really a problem of we don't really know what is buffer bloat and how does it impact the end user. So we believe it's time for a standardized metric of what we call responsiveness under working conditions, which is what exposes problems like buffer bloat. So first of all, we want to measure responsiveness for the end user. And that implies a certain set of things. First of all, a realization that buffer bloat, while typically you think of buffer bloat as something that is a big queue in the bottleneck router that is being filled up, buffer bloat can happen at many different places, right? It can not only be in the bottlenecks router, it can be on the server, it can be on the client, it can be in the server's NIC, it can be in the server's TCP implementation, or even in the HTTP implementation, right? And we have found that in many cases, the buffer bloat in HTTP implementations are way, way higher than whatever you can measure on the internet. So sometimes the problem is at a different layer where you would not expect it. So this implies that if we want to measure buffer bloat between quotes, because all of a sudden buffer bloat is no more just on the bottleneck router, but it can be anywhere, right? If you want to measure buffer bloat, it means you need to use the modern protocols that the end users are actually using, which means you need to use, for example, HTTP2, HTTP3, you need to use TLS, and so on. You also want to measure all stages of the connections, right? If you have a good solution to handle buffer bloat in your TCP stack, but your DNS is still going to go through a shared queue that is completely bloated, well, your user experience will still be very bad. So you need to measure all stages of the connections, DNS, TCP, TLS, and so on and so on. And finally, if we want to use this kind of metric as a forcing function, we need it to be user-friendly, and we need it to be expressing the number in a way users can understand it. So how do we create what we call working conditions? Because in order to measure buffer bloat, in order to measure the responsiveness when under working conditions, we need to fill the buffers, right? Now, filling the buffers can be done, for example, by flooding the network with UDP. That would definitely very reliably fill the buffers, can guarantee that. However, it is not a realistic traffic pattern. Nobody does that. And so in order to measure buffer bloat, we need to create a balance between a realistic traffic pattern while at the same time reliably filling those buffers. And so, for example, a good choice could be running several HTTP2 bulk data transfers, right? Now, on the other side, also with QUIC coming along, well, in the future, we rather would want to probably use QUIC instead of HTTP2 because the buffering can be completely different for QUIC. Now, in order to measure responsiveness, we need to create those working conditions for an extended period of time because we need to measure it repeatedly and get multiple samples to have a stable number, right? And so we need to gradually add flows and monitor the good put evolution to create this kind of a stable condition where the buffers are roughly full. And the good way to do it is the way we do it is, for example, as we describe it in the IETF, in the draft here, is we start with a certain number of connections. As those connections go through TCP slow start, the good put is going to ramp up and it's eventually going to level out. And at that point, the only way to increase the good put is by adding more connections. So we add more connections again. You will be able to see it, the good put increase again, and then it levels out again. And then you basically achieve a state of saturation where your network is as full as it can be with a reasonable networking load. So once we have these stable working conditions, we can then go and measure responsiveness, right? And there are two ways to measure it. The first one is by using those connections that are creating the working conditions. By using these bulk data transfer, we can send an additional GET request from those connections and measure the latency for those GET requests. This is great because it allows to expose bad HTTP2 and TCP implementations on the client and the server side, and it also exposes bad buffering in the network. And the second approach, and maybe orthogonal to it, is measure the latency on separate connections, right? For example, creating a short-lived HTTP2 GET request, which then allows to measure DNS, TCP, TLS, and the GET request while the network is fully loaded. And it allows to expose flow queuing in the network, which is a good property, right? Because it allows to work around some of the issues around buffer bloat. And then we need to, as we gather all of these latency measurements, we need to aggregate those numbers into a single result, because we want to have it being a user-friendly number. And so we can take an average, a 75th percentile, and so on. So finally, as we are doing all these measurements, we then expose what we call a round trips per minute. And we do this round trip per minute instead of latency because it is more user-friendly, which is one of the goals that I mentioned initially, is we want it to be the higher the better. We want it to range from the low tens to a few thousands. And we want it to be a nice analogy to what we call revolutions per minute. And so the RPM number is a good way to present buffer bloat to the users. Now, this methodology is something, is currently a work in progress, and we are very much looking forward to feedback. We have currently an implementation in macOS Monterey and in iOS 15, and we also have published server-side implementations for it on GitHub that I will show in a minute. So we are very much looking to collaborations around this effort to define, to properly define a way to measure buffer bloat and responsiveness under working conditions. In our internet draft that we wrote, we are using HTTP2, and we are very open to other suggestions on how to measure it, because there are many different ways to create those working conditions, and there are many different ways to measure the responsiveness. And so this is really a call for contributions, for people to come and join this effort to give suggestions on how to measure responsiveness. We believe that this will be very useful, and we are already seeing how the tool can be used to actually debug bad HTTP implementations in the wild. And so we believe that this would be very beneficial for the overall user experience. So with that, I'm very happy to take any questions.
Thank you. Martin?
Hi, Christoph. This is really interesting. So it seems like there's two separate proposals here. There's a like a methodology, and then there's a metric. So I actually have one question for each. So for the methodology, these background connection you're raising, are they just downloading an arbitrarily large resource to fill the pipe?
Yeah, yes, that's right.
Okay.
It's just an arbitrary, it's basically an infinite file. Yes.
Right. Okay. And then the second question is about RPM. So what exactly is a round trip? How is a round trip defined? So if they're doing a get, does that imply that an entire resource is arriving, or is there some packet coming back?
So in the draft, we specify also what the protocol would be. And so what we require is that the server is able to provide one very large file, one very small file, basically just 1 byte, and allowed to upload data. And so the small file is used for latency measurements, and because it's just 1 byte, it would be 1 packet. So that's basically it. So in order to measure latency, if we send a GET request, it's just for the time it takes to get the response back. Now the assumption is that on a CDN implementation, the assumption is that this byte would be locally generated, so the CDN wouldn't need to go back to the origin to fetch it. So that is not this kind of latency in the picture.
Nalini, do you want to share your audio? Thank you.
You guys hear me?
Now I can.
Okay, great. Yeah, this is very interesting. Yeah, I'm getting an echo. Hang on. Yeah, no, anyway, I hope you guys are not getting an echo. But anyway, I think this is very interesting. And I would be very curious, because our PDM is performance and diagnostic metrics for IPv6. That is installed both at the server and client end. And the idea of PDM is to separate server time and client time, because this is a problem that many large enterprises have. And I would be very interested to see how what kind of measurements we come out with using your test data. So as I said, I think this is a quite interesting.
Details of PDM, so I'll need to look into it and learn a bit more about it.
Sure, I'll contact you offline.
All right, Lucas, I should probably cut the queue after this.
Hello, can you hear me okay?
Yep.
So just a quick one. You mentioned maybe being able to detect bad HTTP2 or quick implementations, but just a word of caution that there's many ways to be bad. There's lots of things in these specifications that may be a bit optional, and people choose just to not bother implementing them. So I just caveat or try to caveat what you mean by good or this is bad. If this is for like raw throughput or scheduling, these kinds of considerations, it's a very minor point, but I think for nitpickers like me, or people who are really into web performance where the workload's slightly different, just quantifying good or bad might mean something.
Bad. The word bad was probably a bad choice of words. Sorry about that.
All right, I think we're up for time on this one. Thank you, Christoph, and it'd be good to hear more comments on the list, especially from people who have a lot of deep experience with existing IPPM metrics. And now we have Al. Sharing a deck. Are you able to find your slides in there, Al? I know there's a lot.
I'm still looking for the slides, Tommy. Maybe I should just go with the screen.
Here, let me try to see if I can find them there. Yeah, if you want to share your screen, that's fine too.
All right, cool. And I think you still have to give me, oh yeah, here we go.
Yeah, there it is.
Yeah, still, yes, I do. All right, I'll do the screen and let's see. Screen one, I think, is this one. Yes, okay. And allow. And slides. All right, I guess I'll just make this as big as I can. All right, so thanks everybody and for joining in today, and thanks Tommy for the congratulations on the one-way IP capacity measurement, RC 9097. It was a long road, longer than we thought. So last time about the protocol, I gave a, let's see here, I've got the time covered. That's not going to help. So what I wanted to do is basically talk about some special features of the protocol. Since last time we talked about security features and didn't get much traction with that. So it's kind of a unique protocol that we've developed to do this. So we're going to talk about what's new in the protocol, where the functions reside between like a server and a client matter. And first and foremost, thanks to the reviewers. Jan, that's how he pronounces his name, Lincoln, Rudiger, and Greg. So on to the next. All right, so we've seen this in various forms, the protocol setup and phases. We've got a setup exchange, a test activation exchange, and the most important point I want to make about this is that you're actually testing connectivity when your client is setting this up, and also opening ports and so forth in the firewalls and translators and so forth. So these are important parts of the exchange, and it's always good to record when you've lost connectivity to your server or between your client and server. Those are the kinds of things that relate directly back to whether a user has connectivity in general to the internet, specifically to one particular host, but that might be a sort of a catastrophic indication as well. So recording failures is just as important. That's one of my workshop points. But then we're going to go on mostly today and talk about the test protocol. And the test protocol is the where we send test stream PDUs, and the most important part is that we get measurement feedback here. So the measurement feedback is exactly what we really want to emphasize. And so we're going to carry these colors through. The load PDUs are in black, and the feedback PDUs are in blue. All right, and not showing anything else here other than that. Of course, this is the protocol that we're currently using in running code. So here's the test phase operation. I've got two scenarios side by side. I've got a downlink scenario here where the server is in the network, that's on the top. It's in the role of the sender, and the test controller always resides with the server. So that's an important functionality, and it doesn't swap completely when the sending and receiving roles change places. So let's look at this quickly. The sender's deciding what downlink test traffic rates it's going to send at for our classic IP layer capacity measurement. The receiver receives that traffic, and it formulates a reverse path feedback message, which includes loss, delay, and reordering measured on the sent rate and it sends it back every 50 milliseconds. And I didn't even include the fact that it measures the rate here, but that's a fairly obvious thing that's happening. So then every 50 milliseconds, that feedback message arrives at the sender. The test controller acts on it. It runs the load adjustment algorithm and controls the sender rate. It can select a rate in the table with our current logic, and that's kind of what you see depicted here down at the bottom. So we ramp up the rate at first, IP layer capacity on the y-axis and time on x, and you can see us searching for the maximum capacity here in the typical RFC 9097 method and metric. So we reverse some things and change some information that's exchanged when we do an uplink test. So now we've arranged for the sender to do the sending from the client side, and so the uplink test traffic arrives at the receiver. And now the receiver's test controller function is to perform the measurements. And it keeps those measurements to itself. It runs the load adjustment algorithm, and it sends the next rate to be used over the next feedback interval back to the sender. So the reverse path contains mostly the sending rate structure, which is identified in the protocol. And this contains, the size of packets, the marking of the packets, the rate at which they would be sent, and so forth. And someone's looking for me to go full screen, which means I won't be able to see further comments like that. So good. So what we've basically enabled here, though, is that for the test controller logic that we've currently defined, what we've got is the capability to change that logic. And so you could create alternate forms of reaction to the network, or simply changing the rates and the time, rates over time, the packet sizes and their burst composition over time, and so forth. So it's very much a very complete and easy control of the testing situation. I wanted also to mention that we measure round trip time on a sample basis, and that's on the basis of these feedback messages. So we always have an estimate of round trip time going on. Okay, so let's see. I got to hurry through this now. So we've got lots of motivation for the new protocol. It's different from a session sender in that or the reflector. We're definitely not sending packets back every time. It's different from OWAMP in that there's a fetch and sending results at the end of the session. And the security for OWAMP and TWAMP is kind of old and was described as unusual. It was a little bit challenging way back then. So we've had some good comments, as I mentioned, and one of the things I've decided, which made it kind of easy to decide where we stopped with the 02 update, we're going to stop describing version 8 after this version. And so new updates will result in a version 9 or higher versions of the protocol. So that's good. That frees us up. And of course, we've got running code, and the running code's available. You can get that link from the draft. When we see errors during setup, there could be multiple errors. Right now, we're using a hierarchy, where the first bad thing that happens is what gets reported as an error. But we could make that a field with flags. Both of those options are described in the current draft. One of the options that Jan asked for was options for the payload, whether it be all ones or all zeros or alternating or pseudo-random. That helps. Pseudo-random helps out with compression links like on satellite. And then we've got this last one here, which is interface measurements. We're actually in the running code right now. We're actually making diagnostic measurements on the interface that observes all the traffic. So, way back here in a downlink test, if we've got test traffic sharing traffic with user traffic, we can measure that at layer 2, and it's a kind of a hybrid type 2 measurement at that point. Before that, it's purely active. So we've got that going now, and you could make that make a case for that in the layer 2 as well, and maximize on layer 2. So like I said, next steps. We talked about the security features at 111. The authors welcome protocols and revisions to the security modes of operation. But today we talked about what I think are the unique features of this protocol proposal. It can do more than measure capacity, and we've taken a look at that. We'd like others to take a look. And I had a side conversation with Martin last time. With working group adoption, we could get an early security directorate view, and that would help us solve that aspect for this protocol in a way that might go through the IESG a little easier. So thanks for your attention, and I hope there's some questions.
Well, any question? Martin.
I'm sorry if you said this already, but like, how does this relate to RFC 9097?
This is the protocol we're using currently in the running code for measuring RFC 9097. And with the logic that's in the, let me bring this back up again, Martin. With the logic that's currently implemented in here, the load adjustment algorithm, this is what we do. We try to measure the maximum capacity, and we do that based on the feedback that we're currently receiving. And the point I'm making is that you could change this logic, this load adjustment algorithm, to do lots of other things. For example, a hybrid type 2 measurement where you're seeking additional downstream load, and you want to measure the performance of the passive traffic that's alongside of it, at full capacity. So where you may be building up your buffers and so forth.
Okay, sounds like we don't have anyone else in the queue. Thank you, Al.
You're welcome.
Hopefully we'll have some more follow-up on list as well. Okay, and then next up, I think we have Greg talking about EPM.
About it. I can probably share my screen.
You should also be able to share the preloaded slides. Yours are there. Do you want to click that button?
I don't see the button.
All right, I can do it.
Right at the hand button.
That's fine.
Okay.
Here we go.
Okay, great. Thank you. Okay, so this is update on error performance measurement in packet switch network, and let's go. The next slide, please. Okay, so the recap. Their error performance measurement, we define several metrics for the packet switch networks that reflect conformance to a set of predefined service level objectives. And among these metrics, we have the availability and unavailability as a sequence of the time intervals that conforms and do not conform to SLO. Since our last presentation, we have two new co-authors, Luan and Joel, joining us. Welcome. And we updated, we added the section on availability of anything as a service and availability as used in mobile communication, and look at how these two interpretations of availability relate to what we discuss in error performance measurement. Next slide, please. So what is anything as a service? I think that we are all well familiar. It's a concept of services related to the cloud computing and remote access. Almost everything, anything is a service. It's a security platform, software. SD-WAN, so network as a service. Next slide. So as everything, it doesn't come for free. So it has some benefits, but at the same time, it has challenges. And the advantages of anything as a service is it improves expense model because there is a lower capex and purchase and a subscription basis, and as more capacity needed from the providers. And it allows the enterprise to faster adopt new applications and use its expertise of its IT on specifics of its main business rather than in support. But at the same time, anything as a service has some potential challenges. So because they depend on more equipment, on the network connectivity and availability of computing resources, so they might be constrained by their temporary loss of connectivity, problems with the resilience, low bandwidth, and low computing power. Next slide, please. For anything as a service, using a dedicated environment, the availability average is understood as mean time between failures. It's an equation between of a mean time between failures and mean time to repair. And example of failures that's considered, it's a hard drive malfunction in a data center or hypervisor reboot. Mean time to repair is how much time it takes to fix a broken component application to come back online. Obviously, so we can, if we look at this equation, we can see that mean time between failures can be considered as a constant for the particular environment. And the only way to improve availability is to minimize mean time to repair. And that can be achieved by introducing redundancy in their infrastructure, as like with the web or database service or load balancers. In EPM, EPM reflects near real-time availability by measuring the conformance to SLOs and the ability to communicate. So basically, it's a combination of performance monitoring and fault management, monitoring their continuity of the path from the user to their cloud. And using the EPM interpretation of availability, it provides valuable data and more accurate, realistic information about mean time between failures and mean time to repair. So because these are giving us a theoretical estimation of availability, while using their methodology of error performance measurement gives us real-time or near real-time information. Next slide, please. So another domain where we can see there are here about their availability is mobile communication. So the mobile voice and data services, the definition of service availability can be found in Barrack communication positioning, and it's oriented for operators and consumers. So, and it uses their percentage of the number of attempts to their access given service, so successful attempts. But it's only reflects on established connection. It does not reflect the quality of connection. So that now, when we see that it's not only voice, but mobile broadband, so the quality of the connection becomes more important. And that's where, again, the methodology of error performance management and the approach of how availability is determined and measured and expressed allows for better understanding and better quantifying of availability for mobile voice and data communication. Next slide, please. So what we always welcome comments and questions, contribution, cooperation, and we think that this is something that working group might be interested and would like to ask to consider working group adoption. And I see Fan. Yes, please.
Can't hear you if you're talking, Fan. All right, in the interest of time, I think we're just going to have to take that to the list, or you can drop your question or comment in the chat.
Mm-hmm. Thank you.
Okay, thanks. Okay, so now we're on to our quick elevator pitches. These are one slide each. I will display the, oh, sorry, Yang, can you come back on? I can display the slides now. And we will start with some of the draft lead ones. Okay. All right. And again, for these, we just want to cover them in like a minute or two. Please focus on, you know, what should this group be interested about? Why should people comment on it or read your draft?
Okay. I'm Yang from China Mobile. Can you hear me? Okay. The title of my talk is One-Way Delay Measurement based on reference delay. So the background is that end-to-end one-way delay measurement is very important for SLA. As in this figure on the left, we need to know the end-to-end one-way delay of a video surveillance service in 5G network. We can see that the end-to-end one-way delay is the sum of T1 to T4. We propose a new method to accurately measure the one-way delay using reference delay without deploying clock synchronization. The reference delay is bounded and has lower jitter. It can be obtained in deterministic networking. In figure 2 on the left side, the end-to-end one-way delay from the sender to the receiver is measured, and the intermediate network devices are hidden for simplicity. We assume the sender clock and the receiver clock are not synchronized and has some clock offset. In this figure, the delay of the reference packet is stable and bounded and denoted as dereference, and the delay of the target packet is measured and we denoted as dtarget. We will time-step both the reference and the target packet on the sender and the receiver side respectively, denoted as TS1, TS2, TR1, and TR2. For reference packet,
we're out of time. I know you have another slide coming up right after this.
Okay,
so
okay.
We're going to switch to that. If people have comments, you can get to those on the list. Right, so your next one is, again, a one-way delay. Here we go. As quick as you can.
Okay. We propose a new one-way delay measurement method also based on deterministic networking. We can have a centralized control node as shown and used to collecting network information, and the link from each network element to the centralized control node leverages delay deterministic links so that the delay are shown in the figure on the left side, denoted as T1, T2 to Tn, and can be calculated in advance and have relatively stable and low jitter. As shown on the right side, the network element M and N are connected to the centralized node by delay deterministic network. When the net traffic flows from the network element M to N, they will upload flow information to the centralized control node. The transmission delay of flow information is Tm and Tn respectively. And the arrival time of flow information at a centralized control node is Tm prime and Tn prime, respectively.
All right.
Then the delay can be calculated by this formula. And more details are shown in the document. Thank you.
Great, thank you. All right,
Okay.
up next we have Giuseppe.
Yeah, hello.
All right, let me just pull up your, this is the enhanced alternate marking.
Yeah.
All righty.
The single slide is slide 4. If you can go on slide 4.
We are here.
Yeah.
Pitch it to us.
Yeah, the background is that, in a few words, that we already presented the alternate marking data fields for IPv6, and the relevant document is in ISG evaluation. But during the discussion, there was some input from the ISG to consider whether the flow monitor identification field can be extended in order to have more entropy. So, considering this motivation, we propose this draft to discuss in IPPM how to generalize the data fields extension and whether it is necessary to extend the flow monitor identification field. For example, the next header can be used to define these enhanced capabilities. So this is just a proposal for the discussion in IPPM. So we are looking for more feedback from the group, and we already have some discussion with Greg on the list, and we hope to have more feedback. Okay, thank you.
All right, thank you. Anyone, any quick comments while we're switching slides? We have Tal up next.
To start, Justin will give an update on the IOM Linux kernel implementation.
Perfect.
Thanks, Tal. So a quick update on the implementation on the Linux kernel. So last release of the kernel, which is the 5.15 a few days ago, has been released. And it comes with the support for the IOM pre-allocated trace. Next version, which is the 5.16, and it is expected for end of December this year, will provide tunneling support for in-transit traffic so that we are compliant with the RFC 8200. And actually everything is configurable with the IP route 2 tool, which most of you probably know with the IP command in the Linux environment. And so there is a repo, so feel free to have a look at it. We provide some documentation and an example on how you can deploy and configure your IOM domain. So Tal, the floor is yours.
Right, so we have a new draft that describes an IOM profile, which is used by the Linux kernel implementation. And this means that by reading this draft, you can create an implementation which can interoperate with the Linux kernel implementation, and we'd really be happy to get any feedback and comments about that. So thanks.
Thank you. Is this the type of thing that, I mean, it seems a little out of what we normally do in IPPM. It seems more like an ops type thing if we're talking about a Linux specific profile, but be curious to hear that.
it's closely related to IOM, so that's why we thought this would be the right place for it. But if you think there's a better working group for this, we'll be happy to hear about that. Sure.
Okay, it'd be interesting to discuss. All right. Next, we got some in-band flow learning. All right. I'm not hearing any audio, Fan. Any other authors want to speak up or present this? All right. Yeah, seems like we're having some technical issues, so let's move on. The next one we have is simple direct loss.
Slide 6, Tommy, if you have it.
Yep.
If you go to slide 6.
There it is.
Yeah, thank you. So this is a very simple, straightforward draft that defines packet format, message format for the session sender and a reflector to measure the direct loss. It's inline counter stamping, just like inline time stamping. And it's ASIC friendly because the counters are at the fixed location. Supports the alternate marking method as well as 32-bit and 64-bit packet and byte counters, as well as if you're doing measurement for DSCP scope counters as well. So messages are also defined for the authentication mode as well. So it's fairly straightforward draft, and welcome your comments and suggestions on this. Thank you.
All right, thank you, Rakesh. All right. Next, we have self-contained Automark.
Hello, everyone. I'm Zhongpeng Du from Kernel Bio, and this is a draft about self-contained alternate marking mechanism. And in the left, it is the traditional alternate marking method. In the right is the self-contained alternate marking method. We will introduce each very quickly. In the left, the container or the NMS will connect the information from the coloring point and the monitoring point. The monitoring points may be several, many, and they need to correlate the information by using the block ID. And in the right, if we insert the block ID information into the coloring point, also with the color information by occupying another specific bit, we can report the monitor. Report at the monitor point directly target measurement value if needed. So we think it's very simple for the client to join in the measurement environment. Thank you, everyone. That's all.
All right. Thank you. Except we have some postcard-based telemetry.
Thank you. This draft has been extensively discussed in email list, and a major question raised by the chairs and ADs that is that really worth to standardize this approach, or isn't it already covered by some existing draft? I think it's worth to clarify this point. In the family of the on-pass flow telemetry techniques, there are two types: passport mode and the postcard mode. So for the passport mode, the iOS trace is already on the standard track. And in the branch of postcard mode, for the instruction-based telemetry, is also the IOM DX is also on the standard track. And then PBTM covered in this draft is a standalone method as shown in the left side figure. And so, but it's also have some unique issues that need to be solved. Indeed, it's actually this approach has already been used by the SRv6 OEM draft, but many open issues are answered, as that will be covered by this draft. So we hope that this is worth to be standardized in this working group. Thank you very much.
All right, thank you. I think the main question, it's good to have this formulation. The main question I would have is, if the other ones are, defined as IOAM methods, can we define this as a specific IOAM protocol as well? But we can carry that on list. Thank you.
Yeah, it can be, same family, yeah.
All right. And we're just going to keep going. I know it's at time. If anyone needs to leave, they can, but let's get through these last little talks. Nalini, please go ahead.
Yes, can you hear me?
Yes, I can.
Okay, perfect. Yep, so we're going to have a side meeting right after this, and we'll tell you the implementation. I'll just cut it really short. Is everything, just about everything that I've heard on this IPPM meeting could use encryption. It's all really sensitive data. And so we want to, we'd love to work with anybody to do that too. And I'll be contacting you offline, and because we're getting an implementation. So that's it.
Great. Okay, so anyone interested, go to the side meeting. Thank you. All right. We have some user devices, explicit monitoring. All right. Mauro, are you speaking to this?
Okay. This is the draft that is a sibling of the previous one. The idea is to put the probe on the user devices, a smartphone, for example, or PC, in order to have a point that is where it is possible to make all the measurement without dedicate hardware and software inside the network. Or it can be also an additional point to interface to the probes in the network. We can have some advantages, for example, the scalability. The hardware of the user is is very much, so it's possible to have many measurements. The measurements are more precise because we have the point of measurement that is on both the directions. And it's possible also the network monitoring coordinated with probes in the network. So this is about the positioning of the probes of the explicit measurement. Thank you. We can discuss on the mailing list this idea.
Great, thank you. Okay, and then we have our final elevator pitch. Alexander.
Yes, hello. Yeah, this is a brief elevator pitch for a new draft concerning high precision service metrics. The idea is basically to define a new set of metrics that capture whether or not the service that is being delivered complies with a service level objective. For instance, for when you have precision services that require a specific end-to-end latency, you would want to basically capture whether or not, basically your flows are in compliance and so forth. And multiple applications for this in accounting, monitoring, etc. Some examples of the types of metrics that we have in mind are, for instance, you would want to capture the number of packets that were violating an objective, the number of time units that were violated during the duration of a service. And this basically gives you also second-order measures of precision availability. So not availability, but availability during which service can be accessed with agreed on precision. So anyway, so this is just an elevator pitch. The next steps are, of course, to refine the steps and so forth. And also, we would want to ask anybody who's interested in this work to please reach out. Thank you.
Okay, Greg, did you have a quick question on this or comment?
Just curious how that is different from error performance measurement. So we can discuss it probably in a minute, because that seems to be the same idea.
Okay, so I did not. Yeah, let's put this on the mailing list.
Yeah, I think he was referring to the earlier presentation, Alexander, that Greg made on the EPM proposal. So. Sounds like, read each other's drafts and let's discuss on the list how we can kind of combine efforts here.
All right, sounds good. Thank you.
All right. Okay. Thank you all. It's as usual a full session, but I think we made some good progress today. Thank you to co-chairs. Thanks, Marcus, for running the time. Thanks, Ian, for all your service. We shall miss you. And thanks to everyone who came, and have a good rest of your IETF if you're going to stuff tomorrow. And we will see you next time. Bye.